All right. So I am getting a lot of quiz corrections turned in. Thank you. And remember, you're supposed to have the cover sheet, the corrections, and the original quiz. You're not supposed to write on the original quiz because we want to see the old you and the new you, how you've improved. And again, I say this now every day, and you guys are still confused about it. So we'll try again. You have a test on Tuesday that is on the entire packet, page 1 to 42, entire packet. All of the answers are posted on Canvas, and it's in batches, like it says page 1 to 13 is here, and then 14 to 22, whatever. They're all up, so if you need to study over the weekend, which I recommend you do, checking those might be helpful. There is, that just doesn't work. Right, there's an electronic one next to you. And now it's gonna make noise. Go ahead. No idea where it's at. I do have the Jeopardy song rolling in my head. I got one more go. Good enough. Okay, so there is a Delta Math homework for the weekend. It is a required homework for the weekend. It is not all encompassing, meaning not everything on Delta Math, like everything that's on your test on Tuesday, not everything is covered in the Delta Math because it doesn't do all of the topics the way we do. But it's a good review, and whatever we're missing, we'll put together a worksheet for you on Monday. We'll go over any last minute questions Monday, and you have your test on Tuesday. If you have not done corrections yet for quiz 1, they are due Tuesday morning. And if you do not do the corrections for quiz 1, then you do not earn the right to do the test average replacement. And I keep moving it. Those who have turned in corrections already for quiz 1 would be in here. Let's see, I have them from Angel, Aiden, Dante, Bella, Virginia, Ella, Dora, Anya, Zara, Chrissia, and Lindy. And those are the ones that I graded and handed back. So if you turned them in yesterday and you were in this 1.5 thick of paper, I didn't get to grade them yet. So, yes, because Nora, I think I remember you turned them in, but I haven't graded them yet, so they're not checked off. So you need to do quiz 1 corrections as well as quiz 2 corrections. Quiz 2, you're doing those corrections, 1, because it's a homework assignment, and 2, at the end of the quarter, you rock the rest of the quizzes the rest of this year, but quiz 2 didn't go so good, and you want to retake that one. If you don't do the corrections, you don't get a retake. Yes?
Is the quiz 2 corrections also due Tuesday?
Yep.
Okay.
Okay. Any more questions or issues about corrections and retake and replacements? All right, can you guys try this problem? It says, use composition of functions. You want to do it up here? Sure. Use composition of functions to determine if these things are inverses. So her start is correct. She needs to determine if they're inverses. She needs to find f of g of x and g of f of x. And f of stuff is -4 times stuff plus 12. The stuff she's plugging in is g of x. And then distributing negative 4 times negative 1 over x. Hold on. You missed.
It's
Negative 4 times 1/4 is a negative x. And negative 4 times negative 3 is a positive 12. So we get negative x plus 24, which is feeling awkward. So Nora wanted it to come out to x, but it didn't come out to x. That's a problem, but go ahead. And g of stuff is 1/4 stuff minus 3. The stuff she's plugging in is f of x. I.
Aye. So we are or are not taking off if they're breaking it.
That's okay.
But AP does, right?
I need to verify, but I think so.
Okay, bye.
Bye. Yay for calculus. She and I graded calculus papers for 3 hours yesterday. And we're still not done. Yay!
yeah. The functions are not universals.
Okay, perfect. Okay, so Nora was not happy because she's like wanting to force this to come out to the right thing. It says determine if they are inverses. It didn't say, yeah, they are, prove it. So she wanted this to be true. But it's not. F of g of x did not equal g of f of x. And they did not come out to x. They are not inverses. The word, perfect. So, good that you have the confidence to be like, wait a second. But I do want to make sure that you guys can still do f of g of x when they're not inverses, like she did right here. We okay with that? Yeah.
How did you get a negative x in the front?
Okay. First of all, this was f of x. So there was a negative on the 4. So when she distributed right here, negative 4 times positive 1/4 gave me negative x.
Think of it as negative 1x.
Well, and negative 4 times negative 3 is positive 12?
So is it always going to be negative x?
No. F of g of x can come out to be anything. In this case, it was negative x plus 4. If they're inverses, Anasia, if they're inverses, this will come out. Whatever I put in x, I will get positive x out, if they're inverses. So let me show you an easier one. Dante, pick a number.
6.
What's the undo of multiply by 6?
Divide.
Divide by 6. Okay, so g of f of x is g of x over 6, which is 6 times stuff. I got x. All right. On the other side, f of g of x is f of 6x. Well, instead of x over 6, 6x over 6. So if f of g, yeah, if f of g equals g of f and they both come out to x, they are inverses. We've been asking you about more complicated ones, but this is as like slim as I can make it go. Va bene? Prego. Yeah.
Does it have to be x? Can it be like, if whatever if they're the same, but it's like 1?
It's gotta be x. Okay,
I have a question.
yes.
If they both come out to negative x, would they be inverses or it has to be x?
What Dante just asked. Dante, what's it?
Sorry.
It It has to be X.
Has to be X. Could be negative X?
Yeah.
No.
No.
It's gotta be just X.
Yes.
So-
Pick a number, any number. 8.
So it's
When you plug in 8, add 4, subtract 4, you get 8 back out.
Yeah.
Saying negative 8, that's wrong.
technically, like, you can just do the first half, and if it doesn't equal X, you know it's not inverses, right?
Okay, someone else first period said that, and I was like, you know, if we say verify that they are, like show, prove it,
You have to do both sides.
yeah, because, first of all, we're not gonna lie to you, we're gonna be like, they are inverses, prove it. So if you don't get it working out, it probably means check your arithmetic. So, it's good to double check, and if you got an X on one direction but not the other, maybe that means you dropped some negatives or something on the other side. Okay? Okay, blank page. So kinds of topics that are on the test. This is not comprehensive meaning, it's not the full list, but we talked about some of them yesterday. You need to know all the function properties that we talked about, pages 1 to 13 in the packet. Domain, range, increasing, decreasing, poles, discontinuities, piecewise functions, limits from the left and the right, limits at positive infinity, negative infinity, boundedness, maximums, minimums, and if you wanna tell me the biggest number there is positive infinity, what is your actual answer gonna be?
Does not exist.
Does not exist, or there's none, because if you had to write that number on a check, to write me a check to that absolute max, you're gonna be still writing those numbers. Can't get to infinity. And again, Delta Math is required, corrections on both quizzes are due by Monday morning, Tuesday morning. And someone earlier asked, do we need to know the definitions of things? I'm like, no, but I can get at them by asking something like this. Draw a function that meets these conditions. What makes a function a function?
If it passes the vertical line.
If it passes the vertical line test, does it have to pass the horizontal line test too? No,
It's
to
not
have an
one.
inverse it does. Eden, pick a number.
3.
Faustina, pick a number.
6.
Griffin, above or below? Pick one. Stuart, left or right? Right, pick a number. 2. Pick a discontinuity, what type?
Removable.
Removable. Ella, pick a number. 4. And let's see. Try that. Draw a single function. So that means no lines on top of each other. They gotta pass the vertical line test. Draw a single function where all of those properties are true. I know, good times, huh? Rock and roll. Raul's like bummed that he missed yesterday because we're just so fun in here. Yeah, Wes knows.
It's definitely more fun than ours.
Woo-hoo. Hurry down. Yes. Okay, trying to take attendance and it says no. It still says no. Stuart, you have something drawn that meets all these conditions?
I don't have any graph numbers. I'm just.
don't need graph paper, you just need some paper somewhere with some white space. Chrissy is not, yeah, Chrissy is here. Maya is here now. Of all these properties, what is really, what's the first one we should put on there? It's the one thing that has a distinct placement.
Movable at x equals 4.
Movable at x equals 4, okay, I don't know what y value to put that at.
The limit?
Well, I mean, f 3 equals 6.
Yeah. Plot the coordinate first, there is no question about it, f of 3
That's really weird.
equals 6. Do I leave it open or do I close it? Close it, because it hits there. Removable at x equals 4. How am I, yeah,
I just kept it on the same line and had the next point over be removable.
so at 4, if I kept it on the same line, do you mean you did that?
Yeah, is that okay?
That's fine.
Okay. And
There
then-
are choices, there are different things.
Okay.
Did it have to be that height?
No.
No. For it to be removable, Raoul, do I draw a line coming out the other end of this open circle, or do I make a new circle somewhere else?
You can draw a line that continues from there.
So I need the line to come out of that same circle because it's removable. If it comes out anywhere else, it's not removable. Yeah.
Couldn't you also just like go lower and have another open circle? And have
Okay,
it
that was my
continue lower?
question. I asked Raoul, can I move the circle and go out from there?
Yes.
Is that a removable discontinuity?
That's jump.
That's jump, so no, you
But
cannot, Gray, if you go from here to down here, did you have to jump to get from one ledge to the other ledge?
But there's still, the point doesn't exist at that. at
Okay,
that.
it's a discontinuity, I agree with you. What kind of discontinuity? This, could you drive your car across this if you filled in the bridge? No, your car would
So
need
it's
a
not
ladder.
something- It's not both, it's,
It cannot ever be jump and removable at the same
okay,
time.
my bad.
So, oops, Raoul was right that it absolutely must come out of that same circle to be removable. All right, so we've done this one and we did the removable. All right. And jump at x equals 3. How am I gonna narrow that one, West?
Draw like open the circle.
Open circle on top of this spot?
No.
No?
At x equals 3. So like.
So somewhere, maybe down here?
Yeah.
Is that okay? Do I close in the circle? No,
Uh,
absolutely not. Okay, does a line have to come out of it?
Yes.
Which way does it go?
Towards x equals
To the left, okay. And then, Stuart just said, and eventually it needs to go to x equals 2. Left end behavior, y, negative infinity. So that means eventually, somewhere along there, your graph is gonna have to settle off at y equals 2. It doesn't have to be immediately, because it done some wild and crazy teenage things and gone nuts. So let's see, do I have a coordinate drawn at 3, 6, yes. Is it bounded below?
Yes.
Yes. And I filled in this part. If I didn't make this go up, if I made this just go out flat like this,
It would be bounded above and below.
it would be bounded above and below. So I had to make this go up and be like, oh, wild and crazy. Because I said there was only a bound below. Wes, did I lose you on that one?
Yeah. Why does it have to go away?
Okay. Here I asked, which ways do we wanna make it bounded, above or below? They said below, which means it's got a floor, it's not gonna go below this, cool. But if I made this line settle off like that, doesn't it also have a ceiling?
Yeah.
So Dante said we needed to make it go up so that it's not bounded above and below, just below. Maya?
When I did the infinite one, I did it like this way. How do we know that it's this way?
Okay. This isn't an infinite discontinuity, it's as x goes super duper to the negative direction, where does the y value go? I can show you an infinite discontinuity in a second,
It's
but,
like the L's on both sides. Is that what
yeah,
you're saying?
yeah. And then a jump at 3. So there were options, there's variations of this, but this kind of question, I love these questions because I'm not asking you to define things, but I'm asking you to understand what the restrictions of this are, and how do you produce a picture that has all of these things that are true. So do you understand what left-hand behavior means? Do you understand what bounded below means? Means it's only got a floor, but it's gonna bust loose on the ceiling. Do you understand that removable means the road in and the road out have to be at the same height? And Gray, do you understand that jump means it actually jumps
Yeah.
vertically over the y values?
Like, I know that it's jump, I just thought like it could be both. but-
Nope.
Got you.
Someone said something about infinite this way.
If there's infinite at 2, it would be like that. Really not like,
So-
or like, it would be a,
Oh, I actually have a question about
This
that.
is an infinite discontinuity at x equals 0, yeah.
How would you like adjust that if it was, for example, 3 over x? Really that important?
Just because it was
Yeah,
easier to.
Like, cause like when that hits, is at 1, 1, would you make it hit at like 4, 1 instead?
Well, when x is 1, this is 4, so it just it's a stretch.
Oh,
That's
okay,
all.
that makes sense.
Okay, guys, bell didn't ring yet.
Okay, wait, sorry, one more question. What if it was 4x plus 2? 4 over x plus 2.
So, on this, lovely questions. This is our next section, is getting to how to graph rational functions without a graph, like without a calculator. You guys, this is the last packet you're gonna get. Please have a notebook that's dedicated for math by Wednesday. This thing, when are we dividing by 0? When x equals -2, so it's gonna be a vertical asymptote. When x is super duper huge, 18,547,000. 4 cookies to be divided by 18,457 people. How much cookie does each person get? 4 cookies, 18 million people.
A lot less.
How much cookie are you personally gonna get?
Like a
Bajillion.
Damn near nothing. So
Like,
out
you're
here,
never gonna get 0.
right, you're never gonna get 0, but you ain't getting much
Approaching
cookie.
it,
It's
yeah.
basically 0. You're gonna get an atom of a molecule that once
Yeah.
wanted to be a cookie. You ain't getting no cookie. So there's a horizontal asymptote of y equals 0.
And then there's the vertical
And then you can-
asymptote at 0 because it's, yeah.
Well,
No,
you
it's-
made it shift to x equals -2.
Okay, yeah.